Have you ever stopped and wondered what's really happening when milk goes sour or an old nail starts to rust? Those things aren't just random. They're actually little chemical mysteries playing out all around us every single day. So today, we're going to put on our detective hats and uncover the secrets behind these chemical reactions. I absolutely love this quote. It gets right to the heart of things. It tells us that science isn't just about memorizing a bunch of facts. It's about understanding why things happen. So that's our goal today. We're not just going to list what happens. We're going to connect the dots and see the bigger picture. Just think about it for a second. The world is constantly transforming. A fresh apple turns brown if you leave it out. A bright, crackling fire turns a log into a pile of ash. These everyday changes, well, they're the clues to a really fundamental process that pretty much governs our entire world. So what is actually going on behind the scenes? Okay, so to solve any mystery, the first thing you have to do is gather clues. And the good news for us is that they are literally everywhere. So our first step is to just take a look at some of these everyday examples. Now, these things might seem totally unrelated, right? Souring milk, rusting iron, even just breathing. But they're all pieces of the same puzzle. In every single one of these cases, the thing we started with is changing into something completely new. All these clues really point to one central question, and it's the core of our mystery today. How can we be 100% sure a chemical reaction has happened? What's the definitive sign we should be looking for? And to answer that, well, we need to do a little more than just observe. We need to see a reaction up close in a controlled way. So, you guessed it, it's time to run an experiment. Before we start, let's lock in our guiding principle here. A chemical reaction is basically a process where the very nature and the identity of what you started with changes. It's not just a different shape or a different temperature. We're talking a fundamental transformation. Keep that definition in your back pocket as we move on. So here's the plan. We're going to take a small ribbon of magnesium metal. First, we'll clean it up a bit to make sure we get a pure reaction. Then we'll use tongs to hold it right in a hot flame. What we're really looking for is the dazzling, brilliant light it gives off when it burns. And then we'll carefully collect whatever is left behind. And here it is, the key moment. You can see the metallic magnesium ribbon just burning with this incredibly bright flame as it reacts with oxygen in the air. But look what's left over. That's not metal anymore. It's a completely different white, powdery substance called magnesium oxide. The transformation is it's undeniable. Okay, the experiment is done, but now for the most important part of any investigation, right? It's time to analyze the evidence. So I'll ask you directly. Based on what we all just saw, what is the single most important change that happened from the beginning of the experiment to the end? The contrast is just so stark. We started with a shiny, flexible, metallic ribbon, and we ended up with a crumbly, white powder. They look different, they feel different, because they are different substances. So that's the crucial takeaway here. We created an entirely new substance. And that is the definitive proof of a chemical reaction. It connects right back to our definition, doesn't it? The nature and identity of the initial substance have changed. Mystery solved. Okay, so let's circle back to those first clues we talked about. Rust isn't just dirty iron, it's a new substance called iron oxide. Soured milk isn't just old milk. New acidic substances have actually formed inside of it. Every single one of those clues we started with, it was a real-world chemical reaction, creating something totally new. So we'll leave you with this final thought. We've uncovered the secret behind a burning ribbon, sure, but that's just one reaction among trillions happening every single second. The food you're cooking for dinner, your phone charging on the table, even the thoughts firing in your brain, all of it is powered by chemistry. So what other hidden reactions are shaping your world right this very minute?